Hi, in this video I'm looking at parametric equations, what they are, and how to convert them into Cartesian equations. So my first parametric equation we're going to look at is x equals t, y equals t plus 2. Now, what this means is that we've separated out the x and y variables of an equation and represented them independently using a third variable, a parameter, in this case t. So what this could mean is the fact that each coordinate of a function or a graph is represented as an xy value. But in this case, it means that my points are actually represented using these two equations in terms of t. I've got the equation for x and the equation for y that together tells me as t changes where each x and y point is on the graph. And I want to look at how I get back to the original Cartesian equation. So the way we do this is pick on one of the equations and get it so that we have the equation as t equals something. Isolate t on its own. And you can pick either equation, but it's easy enough to pick whichever one's going to be easier to do the algebra on, or the easier to have the nicest equation at the end. In this case, if I pick on my x equation, it's already in that form. I already have that t equals x, because we're originally told that x equals t. And so now I have an expression for t, and so what I'm going to do is I'm going to substitute that t equals x into my y equation. So I'm going to have y equals, and we encounter a t, so I'm going to replace it with what we know t to be, and then I can finish off my y equation with the plus 2, and I would then tidy the equation up, but there's nothing I really need to do to tidy this up. So I'm left with y equals x plus 2 as the Cartesian equation for this parametric equation. So that was a nice easy one. Let's look at another one, a little bit more complicated, but not by much. So my next one is x equals t plus 1 and y equals t squared. So in this case, we can pick either of these equations to find t. I'm again going to pick on the x equation because it's going to be easier to work with. So if I look at this, I've got x equals t plus 1, which means that t is going to be x minus 1 if I subtract 1 from both sides of that equation. So then I can go and substitute t equals x minus 1 into my y equation. So I've got y equals whatever t is squared. So I'm going to put the whatever t is squared in and replace the t with x minus 1. And so you could leave it like that, or we could binomially expand this and get that y is going to be x squared take 2x plus 1. So both of those are valid, correct equations, and quite often you'll leave it in the first form anyway. My last one, I've got x equals 1 on t, and y equals 3t minus 2. So again, we want to pick on whichever one's going to be easier to rearrange for getting t on its own. And I'm going to start off picking on the y equation this time, see where we end up with. So I'll have y minus 2, plus 2, sorry, I've got to add 2 to both sides, equals 3t. So t is going to be y plus 2 all divided by 3. And so then if I substitute my t equals y plus 2 on 3 into x, then I can have x equals 1 on whatever t was, which is y plus 2 on 3. Now, to tidy this up, we of course want to get y on its own. So, well, I've got this happening here where I've got y plus 2 on 3 as the denominator. So that's the same as having 3 on y plus 2. And then to keep going to tidy this up some more and get y on its own, so I've got it in Cartesian form, I will multiply both sides by y plus 2. So that's going to give me y plus 2 times our x equals 3. Divide both sides by x. So that's going to give me y plus 2 equals 3 on x. And then minus 2. So y equals 3 on x minus 2, giving us hyperbola. Now that wasn't the only way to solve this one. It wasn't the only way to solve any of them. And in fact, I think I might have taken the longer path. Because if I look at that same problem and go back to the start and instead have a look at what if I pick on the x equation. So I've got x equals 1 on t, which means that t times x equals 1, which means that t equals 1 on x. And if I then go and sub t equals 1 on x into my y equation, well then I'm going to get y equals 3 times by whatever t is minus 2, and t is this 1 on x, which if we just multiply that 3 in, we're going to get 3 on x minus 2. So we got the same result, and that way was actually slightly quicker. So it doesn't matter which equation you pick on to begin with. In the end, if you do your algebraic steps right, you will get there. What is important is that you isolate t so that it's the subject of the equation, and then sub it into the other equation, and then rearrange so that y is the subject and it's in its nice simplest form.